Okay, so this was the warm-up for today, and we were to show without a calculator, well, to do these without a calculator, so I showed my work here. So 9 factorial is 9 times every positive integer less than that. So 9 times 8 times 7 times 6 times 5. When I got to 5, I just left it as 5 factorial because I knew it would cancel with 5 factorial. And then 4 factorial is 4 times 3 times 2 times 1, which I didn't really need to write. But 4 times 2 cancels with the 8. And 3 goes into 6 2 times. 63 times 2 is 126. Okay, permutations. Now let's remember the formula for permutations. The permutations of n items chosen r at a time would be n factorial over n minus r factorial. So in this case, it's 5 factorial over 5 minus 3 factorial. The 2's cancel. 20 times 3 is 60. We good?
Yeah.
Okay. Combinations. The formula for combinations of n items chosen r at a time would be n factorial over r factorial times n minus r factorial. Now we divide by this extra r factorial to divide out the duplication. So it's 10 factorial over 3 factorial times 10 minus 3 factorial. So it's 10 times 9 times 8 times 7 factorial, which will cancel with this, which simplifies to 7 factorial also. And then 3 goes into 9 3 times, 2 goes into 8 4 times, 12 times 10 is 120. You got it?
I got it.
That's awesome. Okay.
I'm sorry.
Still need these? Okay, we're about to check your homework, so go ahead and pull that out so I can check for completion while you check for accuracy.
Alright, I think I got it.
Okay, if you're watching this video, you're going to have to do a lot of fast forwarding today. We're going over homework now. After homework, we will have a short pop quiz.
With calculator?
Sure!
Are you for
Yeah. Sure, you may use your calculator on the pop quiz.
You better be quiet. I like my house. Can I bring it tomorrow?
Because I don't have a calculator, I get my phone to use the calculator.
How about you use one of those actual calculators on the wall over there? I think you'll find it more helpful.
Michael, I told you that understand it was not 3 times 2, I put 3.
Look at
My record. I put 3 times 2 is 3.
I got 3 foot.
I didn't. Alright, we're gonna have numbers.
I got
Oh, okay. I got 28. How did I get 28? Michael, that's I got 16. Oh, we're gonna have 30? Why? Oh, 30.
I got it.
That's like 1 in 1,000. Actually, that's 20. That's 120. Did we get number 9 right or wrong? How many of 6 books do you read?
So much better.
Oh yeah, I remember it's a dictionary, so it can go like this way, or it can go like that way. So that one.
Yeah, I didn't get a pen.
Oh, that's it's all so much
Alright, we're back now. We're going to talk about numbers 9 and number 10. Number 9, how many different ways can 6 different books be arranged on a shelf if one of the books is a dictionary and it must be on an end? Okay, so here in this picture I have the dictionary on the left end. So there's only one choice right here. This is a dictionary, which leaves 5, 4, 3, 2, 1. It didn't specify which end the dictionary had to be on. So the dictionary could be on the left end or on the right end, which would double this, right? So that's why we get the 240. Because the dictionary could be on either end. It wasn't specified.
They like one. They like what detail on that question.
Yeah.
It's like it's.
Is there anyone like that on the block list?
Oh, there's
No.
Miss Lady's nice person.
No, I'm not mean the first time.
It's like an easy question.
Stop!
It's
just a breeze.
Alright, number 10. Okay, so this multiple choice quiz has how many questions? 5. The first question has how many possible answers? 4. The second question has how many possible answers? 4. The third has 4, the fourth has 4, and the fifth has 4. So it's 4 to the fifth, which is 1,024 possible ways of answering that quiz. Does that make sense? We could draw a tree diagram, but then we cry. That would be
So
painful.
okay.
Yeah, I would cry. Okay. Any questions about the rest of them? Let's move on then. Okay, let's check through 29. 19 through 29. Oh, number 19. Did you notice it said a winner, a first runner-up, a second runner-up, and a third runner-up, which is how many positions?
That's not even cool. Oh, I don't like
Wait a minute.
I got exactly a double the answer. Oh, I'm actually doing really good, except for I messed up on 24.
What's that for 20? I can't include my
22. Oh, the answer is 24.
8 of 2 is 2.
Oh, that's why.
I didn't see the response. I didn't get it. I forgot about that. You can try it. Oh, there's 2 A's, yeah.
I got 13, 20.
No, I got nothing close.
Okay, any issues about the words like algebra, aloha? Okay, let's talk about those one more time. Aloha has how many letters? 5. That's what the reason the numerator is 5 factorial. Now, if we were just doing permutations of a word that had all different letters, it would just be 5 factorial. But the fact that if I switch these 2 A's right now, ooh, did you see I did it? Can you tell a difference?
No.
No. So what we have to do is divide by that 2 factorial because you can't tell the difference between this aloha and this aloha. They look identical, even though I switched the A's. Okay? Over here on the board, I have the word Mississippi. M-I-S-S-I-S-S-I-P-P-I.
Do we have to?
It has 11 letters. So it would be 11 factorial in the numerator. But there are 1, 2, 3, 4 S's. So we'd have to divide by 4 factorial. There are 1, 2, 3, 4 I's. Another 4 factorial. And then there are 2 P's. Divide by 2 factorial. And then we can come out with a number of distinct permutations. Ones that look different.
So, if you're like solving that, if you just find all of them and then just divide without if you found like what 11
can you go with 20?
it was, and then you divide it.
I would let you use your calculator on a problem like that.
Okay.
I wouldn't make you do that kind of by hand. Colin,
You get over 28 and 29.
28 and 29. I certainly can. 28. Now, yesterday we talked about the lottery, and today we're talking about playing cards. We're just talking about gambling all over the place, aren't we? Well, this is just choosing a hand of cards. We're not really gambling. But you have to know about a deck of cards. A deck of cards contains 52 cards. Those cards are divided up into 4 suits. We have diamonds, we have hearts, we have clubs, and we have spades. There are 13 cards in each suit of cards. And later on, when we look at probability, we might say, what's the probability of drawing a face card? So you would need to know that the jack, queen, and king of a deck of cards So each suit of cards is considered a face card because there's a face on the card. Okay, but in this case we don't have to worry about face cards. We just need to answer this question now. So choosing a hand of 5 cards consisting of 4 cards from one suit. That's what this combination takes care of right here. Each suit contains how many cards? 13, and we are choosing 4. But this just represents one of the suits, doesn't it? How many suits are there? 4. So we multiply it by 4. Okay? Now, if this is the 13 and we're going to pull 1 card from the other suits, well, what is 52 minus 13? 39.
4 out of 13, 1 out of 39.
Okay, sure. One more time. This 13, the combinations of 13, choose 4. That's how many different ways I can pull 4 cards from one suit of cards. That's how many different ways I can pull 4 cards from one suit. And it says, and I'm doing 1 card from another suit. So counting principle, how many cards are left? 39. If I've taken this suit out, I've taken 13 cards out. In the deck, there are 39 cards left. But this product right here, the combinations of 13 choose 4 times 39, that's only representing 1 suit. And there are actually 4 suits in a deck of cards. There will not be one like that on today's quiz. Nope.
I got
Didn't do
1/4
it.
of the answer.
Okay, we are seating 5 men and 5 women alternately on a row, beginning with a woman. So if this is my first seat here, it has to be a woman. First seat, woman. How many to choose from? 5. Second seat, I have to alternate them. So the second seat is now a man. How many men?
5.
Okay, third seat, now it needs to be a woman again. So down to 4. And then man, 4. And then woman, 3. Man, 3. Woman, 2. Da, da, da.
Oh, man.
Make sense?
14,400.
All right. Okay, wasn't it cool that 30 and 31 had the same answer?
What?
They do. The combinations of 8 choose 5 is equivalent to the combinations of 8 choose 3. Let's look at it mathematically. The combinations of 8 choose 5. It's 8 factorial over 5 factorial times 8 minus 5. What is 8 minus 5? 3. Now let's do the combinations of 8 choose 3. It's 8 factorial over 3 factorial times 8 minus 3, which is 5. Aren't these denominators the same?
Yes.
Yes. So, the result of finding the combinations of 8 choose 5 and the combinations of 8 choose 3 are the same. Math is cool, isn't it? Cool. Math is awesome.
I guess if you want to look at it.
Yes. And we're going to look at it a different way pretty soon. We're going to do Pascal's triangle, and we're going to look at the beautiful symmetry, and then it's going to tie back in to the combinations. Woo, it's all good. Math is beautiful.
This quiz gonna be good.
I think it'd be good for all but one person.
Was that Bridget?
No, it's
It'll be like.
I can't tell you
I missed 2.
Okay. Alright, if you're watching the video, this is where it's about to get really boring for the next 5 or 6 minutes because we're going to take a really short pop quiz now. And what I'm giving you is just a sample space, what the sample space looks like when we roll 2 dice. And then beside it is the sum of those dice when you roll. Okay? Yes, ma'am.
On the pop quiz thing, did you consider 0 an even number?
Yes. Because anything that ends in 0 is even, right?
Alright, what was number 3? Can you just tell us what it was?
So I sort of just, I got that one. Yeah, me too.
The number can't start with 0, but that wasn't a choice. Because it said it started with the odd numbers, right? So, if it had said it started with the even numbers,
Well, it didn't exactly say that it was an even or odd number. It just said that the number was even or odd in it. And just like, just never considered 0.
So I got like
Or odd
80%.
number. You just had it there. So I did like 5 odd and 4 even.
Yeah.
Yeah.
well, luckily for you, on the first quiz, even though there's 5 questions, I'm grading it out of 4. I did. So far I've had a lot of 5, so I've graded all of 4th period and half of 5th. There's been a lot of 5 out of 5s.
So you get
Not me.
Yes. Except I only made it 4 points. So it's kind of a pop quiz.
Oh, it's only
But it was
4
kind of
points?
like dipping your toes in the water.
Homework is
Yeah.
2, right?
Homework is 2. Alright. It's okay. We were going too long before we had our first test, and there's no quiz. So I wouldn't be surprised if I threw another pop quiz in. Next one's probably going to be 10 to 20 points.
So when my mom goes and checks my grade and it says like something low, I tell her it was 4 points.
I can't even get it to open up to let me enter grades yet.
Yeah, I can't check grades.
So, I don't think you can check grades. I don't think they're letting me because I set up my classes the other day and I cannot get into my grade book.
Oh,
So,
gotcha.
I'm hoping that's everybody and not just a little
Yeah, I can't get to grades.
Yes, Sammy.
Do you use Edmodo?
I don't.
Alright, I just wondered.
Are y'all fond of Edmodo?
I hate it.
No.
I know.
Okay. I tried Edmodo 1 year. It was very difficult for my students to find what they were looking for. It's kind of like Twitter. There's just a huge stream of information. A huge stream.
Tweeter.
And with my website, I think I have it more,
Yeah, your website.
I have it set up where you know where to look. So, I considered moving to Edmodo, but then, I'm not, because my daughter is in the middle school, and I have tried to find things on Edmodo, and I end up very angry
Wait, what grade's your daughter?
and frustrated with the technology being so inefficient that it's highly annoying. So, from a parent perspective, I didn't like it at all. All right, she is now 8.
Who does she have for that?
She has a brand new teacher, and she's fabulous, my daughter says. So,
That's good.
wonderful.
Our science teacher in 8th grade used to make us take tests on Edmodo.
And exams, final
And
exams.
final exams basically on Edmodo.
Well,
Okay,
okay.
everything was on Edmodo, and it crashed halfway through, so then we couldn't
Oh,
go
I
back and
agree.
change
I
it.
2 years ago, I did you know how we did summer work on Google Forms? 2 years ago, I tried doing summer work on Edmodo. That was the most painful thing
That's what.
I've tried. And at that point, I decided I would never use Edmodo again.
Yeah.
Alright, so, because it did have so many glitches. The glitches were ridiculous. Alright, so today we're going to look at some vocabulary. Some you'll be familiar with, some you may not. So is everyone on page 421 in their workbook?
Workbook. Well, I thought I put my Spanish book in my locker, but I put my workbook because I was in a rush.
Whoops.
Whoops.
Alright, so we're going to kind of intertwine set theory with calculating probabilities. Now, a set is just a well-defined collection of distinct objects. Now, generally, in mathematics, when we're talking sets, we're talking about sets of numbers, usually. Each object in a set is called an element of the set. I've also seen it called a member. A set may be specified by writing its elements in braces. So if you're trying to show me you're talking about a set, at either end you would use the braces, so the squiggly. For the set S of prime numbers less than 10 is written this way. Now, do you guys know that 1 is not prime? 1 is considered the unit. It is not considered prime or composite. It's called the unit. And I used to teach the SAT class, and they would always put kind of trick questions like that on the SAT. And so they would have that answer there with 1 included. Of course, it would be the wrong answer. And then they would have the correct answer where you excluded the 1. So the set of prime numbers less than 10 would be 2, 3, 5, and 7. The number of elements in a set can be written in of S. That's the number of elements in set S. And so for set S, we had how many elements?
4.
4. Now we talked about this yesterday, that notation. Now a set with no elements, a set that contains nothing, no elements, is called the empty set. And there's 2 ways we can denote the empty set. That big fat 0 with a slash through it means an empty set, or just an empty set of brackets means empty set. A set of all elements under consideration is called the universal set, and it's denoted by the big U. So here we have some more definitions. These 2 right here, you may be familiar with the words, and this year we're going to add the symbolism to it. The first one is subset. It says set A is a subset of set B if every element of A is also an element of B. And the symbol for subset is this kind of sideways U looking thing. So here's an example. Here's my set A, 2 and 4, and my set B, 2, 4, 6, and 8. Do you see that every element of set A is contained within set B? Therefore, A is a subset of B. Does that make sense? Now, when we see it visually in terms of a Venn diagram, if we have one set that's a subset of another, it's contained completely within that oval. So all of A is contained within B. Okay, the next 2, and they kind of go together, intersection and union. An intersection of sets is a set of all elements that are in both A and B. Now, you've looked at Venns that look like this before, right?
Yeah.
That A and B is that overlapping region, isn't it? Which is shaded in your text. So the intersection was here, A and B. So if we were looking at the symbolism, this upside down U looking symbol means intersection. So the intersection of A and B are the elements that are contained in both A and B. What are they?
2, 4.
2 and 4. Okay, a union is when we bring everything together. A union of sets A and B is a set of all elements that are in A or B. So if we see the word and, it leads us to intersection. If we see the word or, it can lead us to union, A or B. So if we look, A, the union of A is all the elements that are in A or B. So we just list them all. We start with 1, 2, 3, 4. And what else does B have that A didn't have? 6 and 8. Does that make sense?
I just can't jump the brackets.
I can't either. Do you see how this last one just turned out to be a squiggly line? If you are struggling with the symbol here, just make it squiggly. I'm good with a squiggly line. Yeah. All right. The last one is complement. So the complement of a set is a set of elements that are in the universal set that aren't in A. And the way we denote complement is like this. Okay, so if we were looking at the complement of A, said that U, our universal set, for this example, new example, is a set of whole numbers less than 10. And A, once again, is 1, 2, 3, and 4. When we think about the set of whole numbers that are less than 10, that are not 1, 2, 3, and 4, that would just be 0, 5, 6, 7, 8, and 9, right? So that would be the complement. Everything that's in the universal set that's not in A. Okay. We're going to look at two types of probability with this. We're going to look at theoretical probability and experimental probability. Okay. The top of the next page tells us when all outcomes of an experiment are equally likely, the theoretical probability that an event will occur is given by the number of items of the event over the total number of items in the sample space. So this is where we get our favorable over total. Our favorable over total. Now, with theoretical, we're just thinking about what could happen. You roll a number Q. A is the event of rolling an even number. Well, A would just be 2, 4, and 6. B is rolling a prime number. Our prime numbers would be 2, 3, and 5. So what is the probability of A? And it talks it through us here. What does the sample space look like? Well, it contains 1, 2, 3, 4, 5, and 6. So there are 6 elements in the sample space. A, in this case, is even number. So it contains 2, 4, and 6. So that would just contain 3 elements. So the probability of rolling of even would be 3 out of 6, or 1/2. Now, you can do that instinctively without thinking about what all these things mean. I do know that. But when we start looking at union and intersection, it might be helpful to remember some of these things. So what is the union of A and B? Everything in both. So it's 2, 3, 4, 5, and 6. So how many elements is that? 5. So this would be 5, 6. Okay, the intersection. Which ones do they have in common? Just 2. So there's only 1 element in that set. So the probability of the intersection of A and B is 1/6. There's 6 sides on a die. Numbers 1 to 6. Okay. Now, on the next page, it talks about complements. Whenever we do the probability of something happening plus the probability of it not happening, it always has to equal 1. Like if I said the probability of it raining today was 1/5, then the probability of it not raining would be 4/5. We would probably say percentage when we're talking about rain. But that's how we can do it, and you can rewrite that equation all sorts of ways. Now, here we have the sample space for rolling a pair of dice. And we can find probabilities here. We can find probabilities about the numbers. What is the probability that we roll doubles? Okay, well here's the whole space. I've got 1, 2, 3, 4, 5, 6 doubles, don't I? Out of how many possibilities? 36, because 6 times 6 is 36. So what is the probability that we don't roll doubles? 1, yep, 1 minus that 1/6, which would be 5/6. You can also use charts like this to find probabilities. What is the probability that we can roll a sum that is greater than 10? Well, there's 1, 2, 3 of those. 3 out of 36, which is 1/12. Okay, I've got about a minute left. So I'm going to scoot over real quick to the experimental. Experimental, I have to give you data from an experiment. And you just use that data. So if I gave you this data, let's just look. This totals to 100 trials. So how many of them gave me a red? 30. So experimental, I must give you data from an experiment, or I have to allow you to perform an experiment and use that data. Okay? All right, your homework is workbook, page 425. That's quick.